All right, this is a super long note section, so probably in class we'll do this over a couple of days, but make sure you find out how far in this you need to go. Okay, 3 videos up here. I think I'm going to cover all of this. I wouldn't necessarily say you need to go into AP Classroom unless you feel like you're missing something. Okay, number 1, most important concept that we have here, simple random sample. So in 3A, in the first part of this section, we talked about how it's important when you're doing a survey or an experiment that you have a randomized sample of people. So simple random sample is something that you can abbreviate as SRS, a simple random sample. And this is a sample used in a study or experiment that needs to be representative of the population as best as possible. So we want to make it random. Okay, an SRS, simple random sample, allows every member of a population to have an equal chance of being selected. So how do we do this? We can use technology or we can use a table. So let's talk about this for a minute and then I'm going to show you how to use both. So it is, let's say we want to take a random sample of students in the room. So there's 22 of you in class. So numerically, I could label each member of a population, and I can start with 0 or 1. It doesn't matter. You just have to say starting with 0 or starting with 1. Okay? We're going to choose a sample size. So in our class, we have 22 people, and let's say I want a random sample of 5 people. Randomly choose the numbers that will be used in this sample. Well, I can do this a bunch of different ways. I can take 22 numbers and I can write them on a piece of paper and I can label you in the class 1 through 22. I could throw them in a bucket and I could pull them out of the bucket and say I'm going to pull out 5 names. And we would call this pulling names out of a hat. And that is actually an approved stats way to get a random sample. I'm going to pull it out of a hat. And you would say it just like that. Another way is to use a digit table like this. So if I labeled you 1 through 22, we have two digits in here. So my first person would actually be 01, and my next person would be 02, and so on. And I would have to do that because when I get to 22, I'm in double digits, all right? So the maximum value you label determines how many digits you should pull for the selection. So if your max is 0 through 9, you're going to use 1 digit. If your max is 10 through 99, or I'm going to say 0 to 99, you're going to use 2 digits. If you go up to 999, you're going to use 3 digits, okay? So you'll know, based in the real world, which random line in this table of random digits you're going to pull from. So for example, I would say I'm going to pull 5 people out of 22, and I'm going to use line 114, which is completely random. Okay, so one of the things that you have to say when you do a random table of digits is that you're going to ignore repeated values or values that are out of the sample set. So let me say this too, or values out of a sample set. So let's just say that I have a random line right here, and the first digit that I pull, the first 2-digit number that I pull would be 45. Well, there are only 22 of you, so that's a value outside of my sample set, so I can't use the number I can't use the number 45. Okay? So, here we go. Let's do this. Oh, and here's a little AP trick for this. Oh, sorry, I bumped my video. You must explicitly state that repeated numbers should be ignored. So when I say this, values out of the sample set or ignore repeated values. Sometimes you can have a repeated value, right? So if you think about with probability, we can say, and let's go back to this, take things out of a hat. Let's say that I would give you multiple choices. I might pull your name out of a hat and then I can put your name back in. So I have, let's look at this. I have 22 students and I'm going to give candy to 5 students. So I pull a name out and I get Jack, and then I say, okay, well, I'm going to give you more than 1 piece of candy. So I put his name back in and I can pull it back out and I say, okay, he gets candy twice, right? So you have to state whether or not you're going to, whether or not it's going to be repetitive, whether or not you're going to repeat it. All right, so let's see how this works. So label the players in the list below using a table of random digits. So I'm going to just start with 0. It doesn't really matter. You could have started with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my random list here. And it says we are going to randomly use line 104. Well, if I go up here to line 104, I'm just going to highlight it right here. This is my random list. So what I've done is I've taken line 104 and I've put those digits right here for you, okay? And now, because I'm only going up to 9, I'm going to select single digits. Now, if I had 10 people, I would have to do double digits, 0, 1, 0, 2, or actually I could even make this 0, 0, okay? But I go up to 9, I'm going to do single digits. So if I look at this, my first digit here is 5. So 5 corresponds to Jessica. Jessica R. My next digit is 2, and that's going to be Carissa. My next digit is 7, and that's going to be Caitlin. My next digit is 1, and that's Mia. So 5, 2, 7, 1, and now I have another 1. So because I have another 1, I have to skip the second 1 because I can't pull Mia twice. So my next digit is going to be 3, and that's going to be Anna. And these are my 5 random samples. It came from this table here, a random digit table. All right. Now, if I was doing this with double digits, so let's just look at this. Let's just say I'm looking at double digits. The spaces here don't matter. The spaces that are in these in this table just helps your eyes so that you don't use too many. It's just not like this total chaos of numbers. So if I was going to do 2 digits, let's go up here. I would say 1, 5, and then 6, 8, and then 9, 1. So what you're doing here is you're just taking the next 2 digits. So I'll do it down here just so you can see it better. So first 2 digits would be 93. Second 2 digits would be 7. The next 2 digits would be 46. The next 2 digits would be 02. So I would have 93. I would have 07. I would have 46. Again, remember, this doesn't matter that I have a gap there. Okay? All right. So this next part here says, assume that now we're going to use the digits 0 through 54. Use the table of random digits, so this randomly selected 193, to select 4 students from the sample. So if I did this, I would have my first student would be number 37. My next student would be 56. Well, let's look at this for a second. So 2 digits would be 56, but my sample of my students only goes to 54. So 56 doesn't work. All right, my next sample would be 98. Again, this doesn't work. My next sample would be 51, so that works. 87 doesn't work. The next one would be 44. That does work. 69 doesn't work. And the last one would be 25. So 37, 51, 44, and 25. That would be my random sample. Okay. Let's see. The next one right here is assume all of our schools' upperclassmen are combined. So now we go up to 927. 927, and we want to find 6 students from the sample. So I'm doing 3 digits. So my first one is 710, and that is within my range. And my next one is going to be 350. That works. My next one is going to be 900. That works. And my last one is 143. Oh no, that's 6. 143. My next one is 367. And then I have 494. So those would be my 6 students that I would have. And all of these are within 0 to 927. And you can see how random that is, right? Okay, so why would you use a table? I have no idea, unless they give you a table, because your calculator does this. And so I would tell you just to use on your graphing calculator, we want to use a simple random sample. And remember, this stands for simple. Simple random sample. Okay, so this says use the graphing calculator to select 3 players for the sample in example 1. So example 1, that was this one, where we have our names of our people, and we want to have 3 randomly select 3 people. So here's how this is going to happen. So from your calculator, you're going to hit math. You're going to go over to probability. And when we get to probability, you're going to go to random integer. That's what this is, random int. And you're going to go ahead and select that. And this tells us, if we go back and look here at our sample size, we started with 0 and we went to 9. Okay, so I start, my lower limit is 0, my upper limit is 9, and I want to select 3 people, because it says here select 3 players. So my number that I'm going to select here is 3. I'm going to hit enter. I'm going to hit enter again. So here's, it tells me random integers, start at 0, end at 9, pick 3. And it gives me 3 numbers. It gives me number 3, it gives me 0, and it gives me 9. Now I can go back over here and I can say, okay, that's going to be Anna, Tristan, and Steph. So this is Anna was number 3, Tristan is number 0, and number 9 was Steph. So 3 random people. All right, so let's do this one more time, and we'll do this for our example 3. So again, I go to math, I go over to probability, random generator. I'm going to start with 0. My upper bound is going to be 927, and I want 6 students. All right, this is what we just did for example 3. Okay, here are my numbers: 100, 5, 509, 793, 906, 258. So if it asks you to create a sample set and you want to use a random number generator, what I would tell you is just use your graphing calculator. If it gives you a table, you have to use the table. Just like in here, it'll say use the random digits from line 124. It'll give you the table. It'll tell you what line to use. If it doesn't, just use your calculator. It does it for you. Okay? Other sampling methods. Okay, so we can do a random number generator. That's what you're going to probably use the most often. And in fact, you're going to use this all the time when we do an experiment. But we have a couple of other things we can do. One way that we can get sampling is through systematic random sampling. Okay, so hopefully this word systematic right here tells you that there is a system in place here. And this is a rule that we have to select a sample. So systematic is something like every 5th customer walking through the door, or every 3rd seat in every row, or the last 2 names on every roster. So there's a system here that can be done with or without replacement. But we have a rule, and the rule is going to be defined by whatever you put in your experiment. The problem is that this can sometimes introduce bias. So let's think about this in terms of chapel. So you're sitting in chapel and we say, okay, we're going to take the 3rd seat in every row. Well, if we do that, if you think about where everybody sits in chapel, or we're going to take the 3rd seat in the center section. So what you're going to get in the center section are all juniors. So your freshmen and your sophomores that are on the outside are not going to be included in this. Or let's just say we're going to do every 5th student walking through the door. Well, it tends to be that people walk through the door into the SPAC based on classes. You left a freshman class, every 5th customer walking through that door, that might just be all freshmen. So we could introduce bias when we do a systematic random sample. Okay, another one that we might have would be a stratified random sample. And what you'll see in both of these, whether it's systematic or stratified, is it's still random, right? Every fifth customer, that's still a random thing here. So if I have a stratified random sample, then what we're doing is we are dividing the population into homogeneous groups that we call strata. So what happens is the individuals in each strata have a certain characteristic in common. And then we choose a random sample, simple random sample from each strata. So for example, let's go back to the chapel situation. So we have the seniors that are up front, and then we have the juniors here, and we have the freshmen over here, and we have the sophomores over here. So we're sitting in chapel. So this is stratified. They've got group here, group here, group here. Now I'm going to say, okay, from the senior group, I'm going to take 5 simple random samples. I'm going to do a number generator and pick 5. From the junior group, I'm going to do a simple random number generator and pick 5. And so you're already stratified, and then within the stratified, you're going to go ahead and do a simple random sample to pick from each group. Okay? So let's practice this. So here's what I have. So it says our school students, we want a sample of 40 students. The school staff, we want a sample of 30 students. And the town residents, we want a sample of 200 students. So we're going to look at this 2 ways. The first thing that we're going to do is we're going to look at a strata random sample generator. And so the first thing that I have to do is divide into homogeneous groups. So what I would do if I'm looking at the school is I might say, okay, I'm going to have freshmen, I'm going to have sophomores, I'm going to have juniors, and then I'm going to have seniors. And from this group, I'm going to do a simple random sample generator. Now, one thing that you might have is you may have uneven groups. And that's okay. You just have to say, all right, I'm going to pick 5 from each group. It doesn't matter that you might have more seniors than you do freshmen. Uneven groups don't really matter as long as your sample selection is going to be the same from each group. Okay? So from the school staff, we have certifications. So we might have your non-certified teachers or your non-certified staff. So this could be maybe the custodians or IT or your coaches, and then you might have your certified. So those are the people, maybe your teachers in the classroom, and then you're going to have your admin. So we could break this stratified into 3 different groups, and then from 3 different groups, then we do the SRS. Okay, gender, this is super easy. Town residents, we're going to look at female, and we're going to look at male because it's the only 2 that we have. And from this, we're then going to pick out an SRS. Okay, now, if you wanted to do just an SRS, then I'm not even going to fill this out. We know how we can do this. So we would just do an SRS. We could do, let's just say in this case, I've got all of the names of the students, and I'm going to pull a name out of a hat. And here I have all of the names of the staff, and if I take the names of the staff, then I'm going to use a table. And this could be a random number generator from your calculator. Okay. All right, so let's see, where are we at here? Another type of way that we can collect data is from a cluster. So cluster random sample. All right, so a cluster random sample is exactly what you think. We're going to divide our population into random groups called clusters. Now, the thing about clusters is the characteristics of the individuals of each cluster are unknown. So we don't know the characteristics. All right, we're going to choose an SRS of the clusters, so all the members of the cluster will participate, and then we're going to combine the clusters to form the sample. So, for example, if I have Let's do this with this example. Actually, hold on, fix this. All right, so we have lunch students, our schools teachers, and then town residents. So how would I do this? How am I going to create a cluster into a heterogeneous group? Remember, heterogeneous means that we don't know, there's nothing in common, so not in common. All right, so what I'm going to do is I'm going to go into the cafeteria and I'm going to label the tables 1 through 50. And then, so I would have these tables that I would label all the way 1 through 50. And then what I'm going to do is I'm going to do a random number generator, and I'm going to pick, I don't know how many, let's just say there's 9 students. So there's 9 students at a table. And so I'm going to go in here and I'm going to do a random number generator to pick 5 tables. So what happens is it's going to randomly pick 5 tables that are in here, and then I'll survey, or I'll use all of the people at this table and all of the people at this table to get their data. Now, I could have all seniors at a table. I could have all freshmen at a table. Randomly, I could pick all 5 of my tables might be all freshmen, because let's just say that the seniors aren't eating in the cafeteria, so that could create a bias. I could have more freshmen that are in the cafeteria, but that's how a cluster would work. A cluster is like, okay, we're going to take this whole group, but we don't know anything about the group, okay? So if we did things with colors, we could say that we could take the school and we could divide it into wings. So we could say that we have the science wing is going to be red, and the math wing is going to be blue because we're so calm. And then the English wing, that's going to be black because that stresses me out. Okay, so we've got these colors, and then I'm going to do a random generator. And this, let's just say that I'm going to take all of these colors, I'm going to put them in a hat, and I'm going to pull them out. And so I'm going to say, okay, we're going to get red and black are the ones that are pulled out. So we're going to do all of the groups that are in the science wing and all of the groups that are in the English wing, okay? Now, this is biased because you wouldn't have any math teachers, right? But that's what a cluster would do. Okay, and then town residents. So if we have town residents right here, we're going to put these in groups. So we would say that Frisco residents that are zoned for Reedy, let me just do it this way. We're going to say that they are going to be Group A, and that we have Frisco residents that are going to go to Lone Star, and that they are going to be Group B. And then we're going to pull a letter tile from a box. This is another completely random way, kind of like pulling it from a hat. Seems kind of hokey, but it works. And we're going to say, okay, we're going to do just a Group C. And so all of the people that are in Group C would be the ones that would be surveyed or in our experiment. Okay? Let's see. Last one on how we collect our data for sampling. And this is going to be a multi-stage sampling. So what happens with multi-stage is it's a combination of stratified and cluster sampling, and we usually use this with a super big population. Okay, so what happens here is that we would stratify the population. So let's go back to this. So this example here says, given a population of our school students, a sample of 100 students is desired. All right, so how would we do this? So first we're going to stratify. So we're going to stratify the population based on grade level. So we would have freshmen, seniors, and so forth, right? Then we're going to take an SRS of those students from the strata, and we're going to break this down. So we have 100 students from each strata, so 100 freshmen, 100 senior, 100 juniors, so forth. So that would give us a sample of 400 students. Okay, but we only want to sample 100 of them. So then we're going to cluster. So we're going to take the remaining 400 students, and we're going to group these into groups of 50. And so we would have 8 groups. So 8 times 50 is 400. So how does this happen? Well, we're going to cluster these groups based on anything that I want to do. I can cluster them based on where they sit. I can cluster them on anything. And then I'm going to use an SRS to pick 2 of these groups to determine who I'm going to survey. So I would have 50 in this group and 50 in this group, and that would give me my 100 students. All right. Let's see. So here is an example. And what this is, it says a factory bottles hot sauce are put into boxes as they produced. During each production run, sets of 25 boxes are placed on a wooden pallet for shipping, and 10 pallets are filled by each of the 4 machines. So you have 4 machines. So machine, hold this down here so you can see it. Machine A, B, C, D. So we have 4 machines, and we put these boxes into pallets, and they're going to go in these different aisles that we have right here. It says the 10 pallets are filled by the 4 machines. The pallets are placed on a loading dock in aisles as shown in the diagram, like this. After each production run, the quality control department must select a random sample of 200 boxes and weigh them to make sure the bottles in the box are properly filled. All right, so what I want you to do, based on what we've talked about, is this talks about describe how to obtain a random sample of 200 boxes using the stratified sampling method, and then down here using the cluster sampling method, and then a systematic or a multi-system. Actually, I think it just use systematic sampling method. And then work through that, and then I'll come back and show you what my answers would be. Okay, so I started writing this out, and then I thought it probably would have been easiest for me to talk through this as I went. So stratified. So what I would say is we've got 4 machines, and we're going to label our machines A, B, C, D, and then we're going to have within A, B, C, D, we're going to label our boxes 1 through 250. So we know we have 250 boxes here in these pallets. Then we'll use a random number generator to pick 50 boxes from each A machine. So I'm going to get 50 from the A machine. And then and I put in here, do not allow for repeats. So if I randomly select the same box twice, then this tells me do not allow for repeats, which you'll have to do when we actually get into our justify on our experiments. And then we're going to weigh the boxes with selection, and then we're going to repeat for pallet B, pallet C, pallet D. So what that gives us is it gives us 50 boxes from machine A, 50 from B, 50 from C, 50 from D. Okay, so it's random, but it is stratified because we know we're going to get measurements from each machine. All right, if we did cluster work here, what I said is let's make each aisle a cluster. Okay, so if each one of these aisles was a cluster, then we could label them 1 through 10 and use a random number generator to generate 2 numbers. So let's say we do 4 and 9 were our 2 numbers that were selected. We would measure all of the boxes in 4 and all of the boxes in 9. So what that does is it gives us a good representation, again, of all 4 machines, so it's very random. And very predictable here in terms of what we're measuring. So this would actually be a lot easier to go in on a loading dock because we know, okay, we're going to measure all of these. Versus here, we might be jumping around. If we did a stratified sample, we could be jumping around to try to find the pallets that we needed. All right? And then the third way to do a random sample is we know we have 1,000 boxes here, and we want 200 of those 1,000 that we're going to measure. So I could use a random number generator and say, okay, we're going to measure every 5th box as an example. And so then I can go in and say, okay, every 5th box, I'm going to measure that box. So again, it's a very predictable pattern. It's very random. And we know exactly where we're headed with all of these, with our locations, okay? Let's see, where are we at right here? let's go here. Let's go from population to sample. So what we're going to do is, with this one, when we conduct a study to help draw inferences on the population, this is actually our goal, is that we want to take a small population, or a small sample set, and figure out what's going on for the whole population. So we can take a random sample of our school students and find that they work an average of 18 hours per week. We can infer that the average for the whole school is 18 hours per week, right? So the big thing here is the bigger the sample, the better the estimate, right? However, the bigger the sample, the harder it is to get data because you've got to take care of everything within that sample set. So if we randomly select 2 students and they found an average of 5 hours per week, can we infer that the average for the whole school is 5 hours per week? No, because my sample size is too small. It's too small, okay? Your estimate of the population is only as good as your sampling design, and that is what's super important. So we've talked a little bit about bias, and so we're going to talk a lot about bias right now. So bias produces inaccurate information that systematically favors one outcome or another based on who we're interviewing or testing or experimenting. So we have different types of bias, and that's what this is all of our different types of bias. The first one could be coverage. Coverage bias. So coverage bias could over or underestimate a population. So let's look at this. What is one way of over-representing part of the student body in our school? So, for example, if only freshmen were sampled, freshmen would over-represent our sample set. What is one way of underrepresenting teachers at the school? So if only math teachers were in the sample, then other teachers would be underrepresented. Common sense. Makes sense to me. Common sense. Okay, so what we also have here, some other types of bias that we have here, is non-response. So participants cannot be contacted or refuse to participate. And cannot be contacted or refuse to participate. I'm going to change this, and maybe it's not refuse, just say don't participate. So, for example, you get a Wellington survey at school, and everybody participates, but some people choose to not respond to that Wellington survey. So that would be, you were contacted, but you didn't participate. All right? So another type of bias we have is response bias. So a response bias means the respondents underestimate or exaggerate. So basically what's happening here is they are lying about their response. So what is your exact GPA? Well, sometimes people exaggerate this, right? Or how long should a lunch period be? Well, that's dumb because everybody's going to say all day long, right? And so a response bias would be that the responses are going to be inaccurate. So I'm going to write this, inaccurate responses. All right. Another one that we have here is a hidden bias. So hidden bias is something that happens just subconsciously, like you don't even realize that you have a bias towards something. We don't always know their backgrounds to account for their bias. And so sometimes we say that a hidden bias can be an implicit bias. So let's look at this in terms of sampling methods. So where do we get our bias from? So how can we gather the subjects and responses to conduct a survey? So to do this study with a sampling method, we could have right here voluntary response sampling. So a voluntary response sampling could lead to a couple of ours. It could lead to a non-response bias, right? So if you send out a voluntary survey, they could not respond, or it could lead to a response bias. They could give inaccurate data. So members of a population volunteer, this is voluntary response, to be part of the samples. So the reason why we get a bias from this is because individuals with strong opinions are usually willing to participate, all right? So if I said, I'm going to send out this voluntary response sampling that says, if you want to have Chick-fil-A at school, please respond. Well, the people who want Chick-fil-A are going to be the ones who respond, so that would be a bias because they're very, they want it to happen. They have a strong opinion. Another type of sampling method that we can have here is convenience. Convenience, oh, I think I spelled that wrong. Convenience sample. And this happens when we have an easy to reach population. So a teacher only samples one of her classes. Why only one of her classes? Because all those people are in her class. Or this guy only samples freshmen for a survey about home mortgages. Why? Because they're all in one location. One that you see often that pops up on the AP stats test is to do a survey in a coffee shop. And when you do this in a coffee shop, it's easy because you've got all the people in the coffee shop and they'll usually stop and take a minute to talk to you. So survey in a coffee shop could be a sampling method that leads to a bias. They're going to have an opinion if they're in the coffee shop. So types of questions or methods to avoid so that you don't get a bias. So one could be a leading question. A leading question helps you prompts or encourages an answer. Don't you think peanut butter should be banned from all schools for the safety of students? Well, this is a leading question because you could say no, you like peanut butter, but you're like, oh yeah, maybe it should be because there's people who have peanut butter allergy. Or an excellent teacher writes out formal daily lesson plans. Do you write out formal daily lesson plans? Well, if I say no, then obviously I'm not an excellent teacher. So that would be a leading question that would lead to bias because the way you answer this is posed in the question itself. Another one would be a loaded question. And I would kind of say here, this lesson plan one, that's a loaded question, right? But a loaded question contains controversial or unjustified assumption that may require a response that's too broad. So, why are women considered better caretakers for children than men? Well, that's just a stupid question, right? It's loaded because you're saying that women are better caretakers. Or what celebrity has no right being a celebrity? Well, that's a loaded question, right? Could be very controversial. I could tell you there's lots of rappers out there that shouldn't be considered celebrities. You might disagree with that. Another type of question that could lead to bias would be something that we call double-barreled questions. And a double-barrel question, just think about this word double, is it gives you two questions, and when you answer one of those questions, it's hard to know what question you're answering. Do you find that your first semester of college classes is more demanding and interesting than the classes you took in high school? Well, this is double-barreled. Do you find that your first semester college classes are more demanding? That's one question. And interesting than the classes that you took in high school? Well, that's another question. You might find your college classes more demanding, but your high school classes more interesting, right? So this is double-barreled because it's asking two questions. All right, and then the last one here, and this one is choice bias. So choice questions could be totally confusing. Here's a couple of examples. So, how many total high school credits did you earn by the end of your junior year? Well, if you go over here and pick it, let's say you earned 5. Well, do you pick this one or do you pick this one? How do you know, right? So this is confusing. So this question leads to confusing choices. The other one here is limited bias. Which teacher will you come back to visit after graduation? Well, this is limited. What if you don't want to visit any of these teachers? What if you want to come back and you want to, I don't know, visit some other teacher on here? Me, for example. That's not a choice. So this choice leads to another type of question that can give you bias, that leads to bias. Okay, I am going to stop this video from here because there's a lot of stuff in here. Make sure you do these two questions. They're on here, techniques. And then I'll post the answer key on this. And if you have questions, you can come see me in class.